现在正在发考卷，其实想了一下要不要直播，但算了，没关系，就这样直播吧。那么，今天请大家就是分批，然后以小组，就是一小组人，然后来领考卷，或是请代表来领也可以。就是请大家尽量不要一大群聚在一起，尤其是你如果前几天有收到简讯，说你周末出去玩的时候曾经跟受到感染的人有接触的话，请你不要过来，请你要待在家。Now we are giving back the exam sheets, so you can come here to pick it up, but you can ask your friend or you can come here in little groups. So I'm really afraid if there's a lot of people gathered together and we cannot keep the social distance, and that is not very good. So, and especially if you get the text, if you get the message, the cell phone messages during the weekend or on Monday, if the government just informed you that you have already stayed in the same place with infected people, that is very dangerous. So you can please just stay home, stay in your room, and do not come here. And if you get a little bit shocked by your score, don't worry, you can look at the statistics here on the screen right now. This is normal. When we get into electromagnetism, it's very hard to get something like 90 points or even 100 points. It's very difficult, so if you're a little bit disappointed by your scores, and you don't need to be that disappointed, if you look at the distributions, then you can identify where you are. In my lectures last year, the problems are different, but I remember last year the students, the average score of them is around 40 and 50. So you are already much better than my previous students. 大家会被自己的分数吓到，不要太快对自己失去信心。就是你进入电磁学的时候，你就几乎是不可能啊，你就不可能再拿到80分以上或90分以上的分数，这是正常的。因为电磁学它的内涵对于你们现在的生活经验来讲，它确实是太深了。那你如果跟不上的话，你不要紧张，你到30几岁的时候你就跟得上了。好，那我去年大概这个时候也是第一次期中考卷发回去，虽然题目不太一样，但是其实你们今年的题目是比去年更难的。去年的同学的平均分数是40到50分之间，所以你们的表现已经高于平均很多了，所以不要太伤心。你拿到这样子的分数是正常的。那我们也会有很多那个加分题，今后会陆陆续续会有加分的机会，所以不要担心你的期末成绩，你就保持有纪律的持续努力就好了。So you don't need to worry about yourself too much. I am sure from your life experiences right now, or your experiences with working, the essential concept or the philosophy or the mindset in electromagnetism is too hard for you. The depth is really, really deep, and I'm sure when you get into working words, in laboratories or when you really start to work as an engineer, when you really touch the things that, which is really like you have to operate electric field or you have to operate magnetic field, you start to get an idea about them, and then when you come back and to read the theories, and it gets much easier for you. So if you are at the level right now, and then if you are not very satisfied with yourself, and it's okay, it's just normal. And I'm sure when you get more experiences if you get more hands-on experiences, then it's easier for you to understand the theory and to apply it. And I was a little bit surprised because the last problems that you need to use your knowledge and to analyze the problems in everyday life. I thought that it's easy for you to get more bonuses, but I was a little bit surprised by the outcome. Yeah, but I looked through the exam sheets and okay, I understand why things goes that way. Yeah, so we have a table attached with your exam sheets, and you can see how we give the credits. So you can just check through it by yourself, and if you have problems, we have the review session today from 5:30 in room SC162. So you please just take your exam sheet and to the TAs and discuss with her and tell her what's happening inside your answer, and maybe you can make a discussion and then you can rethink about the credits. Yeah, so I hope it helps the communication. 所以大家看到那个考卷的最后一页，我们帮大家订一张表格。那张表格就是我们在改最后一题的时候，我们给分数的准则。只要你有达到一个，就得2分，然后你有达到的就有打勾。那你先看一下。那现在发回去的考卷我有重新看过，所以有些人的分数应该有用绿色的蜡笔有加分数的，那个是我加的。对，那你们再看一下，就如果你有觉得说你的分数还有讨论的空间，然后有需要修正的，请你在今天的5点半到那个 SC162，就那边有一个讨论的练习课，今天特别开的，你可以跟改题目助教讨论，你们可以讨论之后，然后调整一下分数，然后请助教当场登记。好，所以你先看一下 ，OK。那么我还有什么要特别说的？看一下，突然之间脑袋一片空白。好，我们会在今天的演习课请助教都先公布参考答案。好，所以请你今天先去演习课，你先看一下我们的标准的参考答案，然后跟你自己的答案对照之后，然后呢，你先做第一轮修改。如果你跟助教讨论最后鸡同鸭讲没有结论的话，那你就星期5的时候你再来找我。好，大概是这样。那么有3个大题，应该是大部分大家比较有问题的。好，第一个是第一题的 current on copper wire. We just summarized a little bit. I mean, the TAs and I, when we were correcting the exams, we find there are 3 popular problems. The first one is the third case in problem number 1, the current on copper wire. I already explained it in the last lecture, but I will explain it again on Friday. And then the second problem, electric field in media. This is, I will do the derivation again for you. But I already copied or scanned a lot of extraordinary answers, so I will show it to you on Friday. And another problem is in the problem section 4. The first one and the second one is explained in the lecture. So if you check through the lecture slides, and then you can find the correct answer. And the third one is, this is difficult. The third one is really difficult, so I will explain it on Friday. And the fourth one, that is a question for you, that is a problem for your creativity. So I picked some answers which is really creative, or just pick some prototypes, and then I will show it to you on the Friday lecture. So this is how we go. OK， 所以我们今天的演习课，请大家先对标准答案。然后呢，在星期五的时候，我会解释大概有3个问题是，我们看答案就知道，应该大家会比较有问题的。第一个是，第一题的 current on wire。所以这题呢，我在应该是上次上课的时候，我有解释过，但是我星期五会再解释一次。然后再来是第二题，第二题呢。今天助教应该会给大家看一个表格，就是他在看你的图的时候，他到底在看哪里。好，所以你们今天先去演习课先看一次。那我星期五的时候会再解释一次，而且我会给大家看一个真的很优秀的答案，就是物理的推导是完美的，然后艺术也完美的。对，所以我星期五的时候会给大家看。然后再来呢，还有最后一个大家比较容易中箭落马的问题，好，这题真的很难，就是第4大题的第3小题，请大家解释你的触控萤幕，而且是电容式的触控萤幕是怎么运作的。你这题呢，在中文的世界你找不到正确的答案，我找过了。对，我自己有找过，我就发现，在中文的世界没有人给出正确的答案，但是在英语的材料里面，在 YouTube 上面其实有蛮多影片，他们的解释是真的是很精准，而且很正确。那我星期3的时候再解释一次给大家听。第4题，这题基本上是给大家就是看大家的创意啦，然后看你能够考虑各种。电子材料的特性，看你的深度可以到哪里。所以星期五我也会给大家看一些我觉得真的很有趣而且相当有深度的答案。好，所以呢，我们的检讨的流程差不多是这样。OK， 好。So this is for the exams. And we are going on with the lectures. 这张方案，上次，为什么这个图不见了？不会吧？噔噔。原来不小心被我放错地方了。Okay, so as far as I remember, we stopped here in the previous lecture. Here is a comparison between the electric field and the magnetic field, and the electric force and magnetic force. So now we see two different behaviors. The behaviors of charges in the electric field is like this one. So if you have a configuration like this, here are the electrodes and here are the direction of your electric fields, the charges in the electric field always moving in the same direction, just along the electric field. So the direction of the electric force is just simply parallel to the electric field. But here's the situation in magnetic field is different. If we have a charge, and here in this picture, in this configuration, we have the magnetic field vertically going inside into the screen. here right now. So you see the crosses, and you know here are the magnetic field which is going into the spring. But the electric charges here is moving in a direction which is perpendicular to your magnetic field. They are not moving in the same direction. The charges is somehow moving in a circular way. It's running on a circular motion. It's rotating with respect to the magnetic field. You can take the direction of the magnetic field as the axis for the rotations, and the charges is spinning around your magnetic field. So basically the picture is like this. And the direction, we can also apply the right-hand rule on it. So if I put my fingers, the 4 fingers, on the direction of the velocity, if I put, how does it work? Yeah, if I use my 4 fingers, if I put them on the direction of the velocity, and then I rotate my 4 fingers to the direction of the magnetic field, and the direction of my thumb is for force. Okay, so this is how we apply the right-hand rule. And in the videos that we showed in the last lecture, you can see that when, what was he doing? As far as I remember, he was increasing the strength of the magnetic field. Yeah, he was increasing the strength of the magnetic field, and you can see the radius of the circle is getting smaller and smaller and smaller. Finally, you see a perfect circle of the trajectory of the charges. So this is how magnetic force is working on charged particles. And here's a table for the comparison, and you can check it out by yourself. But now then we are applying symbols and numbers. So here's the real calculation. Here's the motion of a charged particle in a uniform magnetic field. Okay, so basically all the directions are not changed. So here's the direction of the magnetic field, direction of the velocity, and by applying the hand rules, and we know that this is the direction of the force, then how about the magnitude? Okay, and now we will convert. Now we are linking the forces from magnetic field to the forces that caused motions. So now we are linking 2 kinds of forces together. So first, this is the link between them. So we should apply the Lorentz force law. This is for the magnetic force. And then we convert, then the force is applied on the particle, and the particles start to move. For every kind of movement, then we apply the Newton's second law. So the 2 essential partners. Okay, so this is for the motions, the mass, acceleration, and this is the force that we applied, but the force is the magnetic force right now. And here's just the right-hand rule. This is the outer product of velocity and magnetic field. Okay, and we just analyze the velocities by ourselves. And in this configuration, we have right angles, so it's easier for us to do all kinds of, so it's easier for us to recognize the direction. And now we can apply we can just turn the vector product into a product like this. This should be the magnitude of the vectors. So Q. Why is he applying the absolute value on Q? I'm a little bit confused. Yeah, but let's leave it this way. 我有一点吓到了，就为什么 Q 这边要绝对值？因为这 Q 的正负号还蛮关键的，它会决定你是往左手就是你是左旋还是右旋是 Q 决定的。它这步下有点太大了，请 请大家平常在自己推导的时候不要这样做哦，就是 Q 的正负号你要保留。好，然后再来是 then this is the velocity, this is the magnetic field, sine theta. Theta is this angle, this one. This is the angle between the velocity and the force. Okay, and this is because of the outer product. I was a little bit shocked by the absolute value because the positive or the negative charge will decide if the charge is running this way, right-handed, or if the charge is running left-handed. And this is quite essential for the spins. So if you suddenly change your charge into absolute value, this is a little bit too bold. So usually you make mistakes on it. So when you do the derivation by yourself, you should keep the polarity of your charge. It's better. 然后我们在做分析的时候，我们通常只要是旋转的东西，我们看的第一件事情就是你是左旋还是右旋，所以我对这个有点敏感。So, and usually when we are working, when you are analyzing your circular motions, the first thing is you have to see if it's left-handed or right-handed. So I was a little bit sensitive to the absolute value. Okay. Yeah, and in this case, the theta is 90 degrees, pi over 2. Then it turns into 1, and it's very simple. Now, this is the strength of our force. This is also a little bit too fast. We already know that it's running in a circular motion, so we directly apply. You can say that it's applying. It's coming from here too. Yeah, it's okay. So we just simply apply the equation for the centrifugal force. Okay, it's the forces that dragging your charges and turn in the direction and make it a circular motion. Okay, so this is V squared over R. So we are quickly just applying the equations into it. Now the important point is if you take these two and if you rearrange those parameters a little bit, we can find this is the radius of your circular motion, the mass, the charge. Usually you cannot change it. If you pick the charge, if you pick the particle, then it's already decided. But the velocity and the magnitude is something that you can change, you can tune. So if you change the velocity of your particle, if you change the strength of your magnetic field, then you see different radius of your circles in the magnetic field. This is important in the applications. And then here's another thing which is very important for experiments or for some theory is very important too. So when you are looking at something which is spinning like that, first we look at the chirality, left-handed and right-handed. Then second we look at the frequency of the spins. So usually we check these two things first, and then we measure the speed of your spinning particles. So usually we do it in step 1, 2, 3. And here's how we link the frequency into your material parameters. So here's the angular frequency. And angular frequency is the amount of angles in a unit amount of time. And this is something you can calculate it by the velocity divided by r. So the velocity is the length divided by time, and length divided by r, giving you the angles. And the VR, and then you can rearrange this one a little bit. You can put the R to the denominator and the others to the other side. Then you can have the frequency is directly proportional to the strength of the magnetic field. This is very important. This is not intuitive, but very important, but very characteristic. 就是你可以看到它那个 charge 这样转这样转这样转，我 我们通常在做实际上的分析的时候，我们看的第一件事情是左旋右旋，第二件事情是它这样转圈的频率是多少，就是它1秒钟它会转几圈，然后再来我们才会从那个1秒钟转几圈去判断，比方说什么速度啦、强度啦之类的比较 secondary 的一些参数。那你要怎么样把频率跟你的材料参数或者实验环境要想把它连接在一起，就是这边，所以你会看到呢，就是你的电荷的量，这是 particle 的 mass， 然后再来呢，你的频率其实是会跟你的磁场的强度刚好成正比。好，所以他们的原因是因为这个，而且它的推导有一点曲折，就它不是一个非常直观的东西。不过因为频率就是你1秒钟转几圈，这个行为非常的有标志性，所以我觉得我们会很注重这个东西。And you can convert it to period too. So basically, frequency and period are just exactly the same thing. You just do some conversions and you can get both of them. I am a frequency person. I like to use frequency. 我自己比较喜欢频率的，但是你也可以用周期去思考这件事情。Okay. Yeah. And here's a little summary for what I've just described. So here's another name. This is called cyclotron. 就是环形加速器，或是环形振荡器，你两个都可以。cyclotron， 好像在科学研究环境比较常遇到。好神奇哦！我们在工业里面好像很少遇到那种要用很强的磁场的场合真的很少。对，好，所以 cyclotron 比较常在科学研究的场合遇到。I was just thinking or reminding myself a little bit. Well, it's not very. I don't see big instruments which create strong magnetic field like a cyclotron in manufacturer or fabricators. No, not that much. Usually we see big cyclotrons in academic research centers. That's the places that we can see big cyclotron. Yeah, okay. But this is how cyclotron works. So we just derive the equations and you can see that here's the relation between the radius, the velocity, and the magnetic field. And this is something that you can imagine by yourself. Even you don't know the mathematics, but you can just think about it and you can go, that's it. Because if your particle's initial speed is large, if it's moving in a really fast movement, then of course if you want to bend it, it's hard, and then you have a larger radius. And here's another thing which goes another way around. If you are bending a particle, if you want to make a turn on it, then if you have larger magnetic field, and then of course your bending radius is getting smaller, you have a bigger curve. You have a bigger curvature. But if your bending force is weak, and then it takes a very large radius for the curvature to make the turn, so that's it. That's something that you can just imagine it really by your intuition. 好，所以这是我们刚才推导出来的公式。但是其实，我会特别把这张图摆在这边，是因为大家其实不用太花脑筋去记那个公式，因为其实你稍微想一下，你就知道事情会变成这样子。就是如果说你的带电的电荷它本身一闯进来的时候，它的速度就很快，那你要给它转一个弯的话，如果它速度很快，那你就要花比较多的力把它转弯嘛，对吧？那 假设说你的速度比较慢的话，然后呢，它的半径就比较小，因为它很容易就跟你拐一个弯。对，那现在我们从另外一个方向想这件事情，就是假设跑进来的 particle 它的速度都没有改变，然后呢，你现在是操控这个粉红色的磁场的强度，你想要操作一下你的 particle， 然后改变它旋转的那个 curvature 的话，那假设说你家的磁场比较强，然后它的 curvature 比较大，然后半径就比较小。对，那如果说你的磁场就弱弱的不够力的话，那你的 particle 就是会转一个很大的弯，然后就不见了。对，所以这个是你可以稍微思考一下，你就会知道说为什么我们的 equation 会变成这样。好，然后呢，到这边目前为止还行的话，状况我们再把它变得稍微复杂一点点。So now we make the situation a little bit more complicated. So in this case, this is like if your particle is entering your magnetic field this way. So if the velocity is perpendicular to your magnetic field, it's running in this way, then it starts to run in a circular motion. But if the velocity is not really in plane, if the velocity is a little bit tilted to the z-axis, so here we make the definition. The xy plane is the plane for the rotation, but if you look at it in 3 dimensions, so use a little bit of imagination. If you look at the coordinate system in 3 dimensions, this picture is actually a cross-section if you look at it from this direction. And if you make a cross-section here, then you can see this is the circular motion. But if you somehow make a kick on your particles on the z direction, many things can create that kind of kick. You can apply electric field to the z direction, and you can push it on the z direction, or maybe when your particles, when it's entering here, and the direction is a little bit tilted to this direction, there are many different kind of methods to create a kick. And then we have another velocity on the z direction, then it creates a helical path. So your particle will be spinning in the path is looking like a solenoid. So it has a helical path, and it's spinning this way and going forward at the same time. 好，所以大家可以看到，我们左边那张图，我们是在 XY plane 上面去分析它。如果你现在扩展一下你的想象力，从2维到3维的话，这是我们的3维空间。然后呢 ，XY 是在这里跟这里。如果你在这里切一个截面积的话，然后你从 z 方向往这里看进去，你就会看到说，这2个方向不一样，请他自己镜像旋转一下，对，然后你就会看到啊，它是在 xy 平面上面是以一个圆周运动在旋转，没错。可是如果你在 z 轴上面呢踢一下你的 charged particle， 那么你的 charged particle 呢就会在 z 方向上面有一个速度，然后呢它就会呈现螺旋状的一直往前前进。好，这还蛮有趣的。我们有很多方法可以制造那个在 z 方向上面的运动。你可以加电场，你可以推它一下，然后呢，或者是呢只是很单纯的你的电荷飞进这个空间的时候，它就不是在 xy 平面上，它可能在 z 轴上面有点翘起来。如果是那种状况的话，它就会呈现螺旋状这样子一直往前动。OK， 所以这个就是在3维里面，它的状况会变得稍微比较复杂。所以其实你要在磁场里面操控电荷是很困难的事情的，因为你可以思考一下，你其实很难把一个电荷维持在 xy 平面上面，让它歪掉的理由好多哦。所以这是一件很困难的事情。So in real applications, it's very hard to operate a charged particle in magnetic field. So If you look at analysis here, it looks very simple. But when you're really operating it, it's very hard to keep your particles on the XY plane. So we just checked it through, and then you know that there are so many reasons to make the charged particles drifting away from the XY plane, isn't it? So it's really, really hard to operate charged particles. And here are the engineers are creating every kind of magnets to trap the charged particles or to maintain the path of the charged particles in a designed plane. And they created every kind of magnets and magnetic fields. If you are very interested, you can look around on the internet. The dipole magnetic field, quadrupole, octupole, hexapole magnetic field. There are so many different kinds of magnetic field to keep your helical motion as thin as possible, as straight as possible. 你有兴趣的话，你可以你可以上网查一下所谓的磁极呀。我们现在都是在处理偶极 dipole， 然后其实磁极还有，比方说 quadrupole 4极 ，hexapole 是6极，然后 octupole 是8极、16极，都是以偶数上去的。但是你把这些各个就是各种不同的那种 pole 的磁铁排在一个轨道上面的时候啊，你如果排得对，你就可以把你的 charge 这样子 spin， 然后喷出去的几率，你可以降到越来越小，而且你可以让你的 charge 就是那个 spinning 的螺旋变得很小，然后它就几乎可以忽略这样子。那我会知道这件事情，是因为我自己以前是在做对撞机实验的，然后那个对撞机实验就会有很多工程师要负责处理这个东西。那天然的磁铁不可能制造那么大的磁场，所以他们都是用那种电磁铁在处理这些事情。你用那个电磁铁，你可以制造随心所欲制造各种叉叉扣，而且你磁场够强的话，你还要用到超导体去做你的那个 wire。因为你如果不是超导体的话，你的电阻太大，你无论如何都没有办法让你的磁场强到那个程度。OK， 好，所以给大家一些资讯。喜欢磁场的同学，你们可以往这个方向发展。好 ，That is a really professional job to create magnetic field and with dipole and octopole and hexapole, everything. That is a really professional job, and we give them high reputation. 那个真的是专业人士了，我们都非常的尊敬他们。Okay, so here's a summary. Lorentz force law. So now we are combining the forces from electric field and magnetic field. And here's the linear application, and here's the vertical application. Okay. And we are combining the QE and Q and vector and outer product and magnetic field. So if we have electric field and magnetic field at the same time, usually they coexist, usually. In the way that we created, usually they coexist. Then you have to consider the two forces at the same time. 通常因为我们现在的磁场你要可控的话，我们通常都是用电磁铁去制造，然后我们的实验的空间里面基本上都会有电场跟磁场会同时存在。对，所以我们大部分时候我们是用 Lorentz force law， 就是电场跟磁场对于一个 particle 运动方向的效应，要全部一起考虑进来。好，这边是一点小 note， 你可以再把它加上去。Okay, and here is another example for the Lorentz force law. We just explained how the helical motions is created, and here's another application. Here is like we don't want helical motions, but there are something that we apply the electric field and magnetic field, the two forces, and we'll try to make it balanced. For example, if you're creating spectrometers, if you're working with mass spectroscopy, then this is the technique that we are using. So the configuration is like this. We have the two electrodes and the electric field is going this way on the horizontal direction. And the magnetic field and the electric field are crossed. Now we set the magnetic field in the direction which is pointing into the screen. And in your mind, please keep in mind they are vertical to each other. They are in an orthogonal direction. But this time we are shooting the charges into the two fields this way. It's going from the bottom, going inside and going here and go out. Now our task is we would like to maintain the straight path of your particle, and we would like to maintain a constant speed of it. And how do we do it? So now the task is we have to create a magnetic field which is in the same strength as your electric field, and that then point into opposite directions. So this is how we do it. So when the two forces are balanced, the total force is 0, then your charged particle can move through the gap with a constant speed. It can keep its inertia and keep going in the same speed. 所以我们现在这个技术，通常是在做那个质谱仪的人会用到。质谱仪就是你现在有一些 particle， 你想要测量它的质量是多少的时候，那我们就会用这招。那你现在的任务就是你有一堆 particle， 然后呢，它有些 initial speed， 这个是你可以控制的，你不知道它的 mass 是多少。那么你现在想要做一个精准的量测的话呢，有个技巧，就是你可以制造一个电场往右边指过去，然后呢，你故意制造一个磁场往左边指过去，然后如果这两股力的强度是一模一样的话，你就有点像是把你的 charge particle 夹住那种感觉，然后你的 charge particle 就可以以它的初始速度完全不改变，然后顺的从那两片电极中间飞过去，然后可以达成这样子的条件的 particle， 它必须要满足一些条件嘛，然后你就可以去筛检你的 particle 有没有符合你想要的条件。所以这都是质谱仪，然后或是做 particle selection 的人在做的工作。好，通常那个速度这样出来以后，后面还会有一些东西啦。对，后面还会有一些东西，通常就是会让，我想一下，我今天脑子有点不好使，我有点忘记它后面会加什么东西，然后可以把不同的质量分解出来了。对，我有点忘记。好，如果我想到，我再给你们看图片。对，我今天不知道为什么脑子顿顿的，有点不好使。好，但是呢，我们这边想要给大家看的是，假设说你要满足这样子的操作，你想要成功让你的 particle 以固定的速度穿过去的话，那么 then the condition is your force from the electric field and the force from the magnetic field should be equal to each other, and then the velocity will be just equal to the ratio between the two fields. Okay, so this is what it is. What if they are not equal? If they are not equal, then, for example, if the electric field is stronger, then your particle is moving to this direction. If it has a force, then it's proportional to the mass. Okay, I remember what's going on. Okay, so if they are not equal to each other, then the particle will have, usually it's easier to think with the electric field. They have an acceleration to the right hand side, and the force and acceleration and mass, they are tightly linked together, and that's the way you separate the charge. Yeah, okay. 好，因为之后会发生的事情，通常是这个 charge 它会出来以后，它会拐一个弯，然后通常会做成比较重的 particle， 就是因为它惯性比较强，就一直往前，然后比较轻的 particle 出来之后，它就是会转一个比较大的弯。那你就是在后面有个侦测器，你就在那个角度上面扫描，就是你这样扫描扫过去，然后你这边有很多不同的角度嘛，然后你每一个角度就会对应到个 mass。通常的设计是这样，所以呢，要么是它在后面会再特别加一个可调控的电场，要么就是它在里面，它就会先调，它就会让电场比磁场大。通常应该是这样子处理的。好，Yeah, this is how we apply the Lorentz force law. So this is a little bit complicated. So we know the field, but if you want to convert it to the force, then you have to apply the second step. The first step is we get the electric field, we get the magnetic field. Then we have to do the second step. We should apply the Lorentz force law to convert it into the force. 所以大家就是知道了，我们在做这些事情的时候，先把电场跟磁场先分出来。然后如果说你要再来的第二步是你要使用劳伦兹力定律，然后呢你才能够把场再转换成力的方向跟力的强度。好 ，OK， and here then we are a little bit more complicated. Now we are working with charges, and if we have a lot of charges and they are running in the same direction, then we get the current. And now we just look at how the current is pushed in magnetic field. I like this experiment very much because it's simple and it's very clear about what's going on. So we look at it first. But it's really quick and it doesn't have any analysis on it. We do the analysis on another video. So that was the current on wire. Stop. That was the current on wire. And you can see that when we turn the switch on, but the switch is designed in a way that we can switch the direction of the current. The current is running on the wire, and if the current, I don't know the direction of the magnetic field, so sorry I can't tell you how the Lorentz force law is working on it. But you can see that when he is changing the direction of the current, when he switches from different direction, the wire can be jumping upwards, or the wires can be sort of pushed downwards, isn't it? So here you can see the direction of the magnetic field is sort of this way. Let me draw it. Sorry, I don't know the polarity, but I'm sure the direction is something like this. I usually use red for magnetic field. And the direction of the force is either going this way, it's going this way, force is pink and fake force. The force is either going this way or going this way, depending on the direction of the current. The current is running here on the wire. Yeah, so you can see, so this is a little bit complicated, isn't it? Yeah, things, it's very easy to get confused when you are analyzing everything and you see everyone is using their hand and doing strange poses like that. Yeah, that's what happened in the lab when we are working with the magnetic forces. Yeah. This is the current. This is the magnetic field. I use double arrows for the moment and use the force. Current, magnetic field, force.好，这个实验就一瞬间就做完了。但是呢，你要分析它的时候，你就会发现这事情有点复杂呢。就是第一个，我们刚刚很直接可以看到的，它这上面没有标示出南极跟北极，所以很抱歉，我没有办法告诉你。对，第一步就缺了，所以对不起，我们马上用劳伦兹定律把它的方向都判断出来，但至少我们会看一下那个轴线。我们先看一下轴线，就是这是磁场，磁场是在两极中间。然后呢，我们这里有一个电流，电流是流在我们的 wire 上面。然后你可以看到它这边有一个 switch， 它是在改变你电流的流向。那它电流流向改变的话，你要么你的 wire 是往上垂直的往上去。那如果你切换另外一个方向，就是它是垂直的往下，好像背着神秘的手这样子，这样拉下来一样。好，然后如果我们知道方向的话，你就可以用你的右手定则，你可以去做判断。对，我刚刚会突然笑起来，是因为我想到我的学生在服务实验的时候，我们有做这个实验，然后就看大家很可爱的，就是那个脸很靠近，然后一直用大家的手就开始做出各种奇怪的姿势，然后都搞不清楚。你就会觉得，真的是很辛苦，但是蛮好笑的。对，反正我们做磁场实验就是会这样子，就常常会3个方向，然后就常常会搞不清楚。好，也是很痛苦啦。就是如果你实际上在做实验的时候，你就会觉得超痛苦的。那么这边是我觉得这个 video 也不错，但是它有点麻烦，就是它的wire是左右漂移。所以在制图上面有一点麻烦，但是我觉得他的实验做得比较好，因为他有很清楚的告诉你方向是什么。所以我们再来看一次这个比较，我们来看一次这个比较严谨的实验。
So I have here a large magnet, south pole, north pole, so the field is pointing up, and then I have a big, copper tube, which is connected to the wires here. And there. When I connect these here, electricity will flow through this guy, through the red, through the copper tube, and then up through ground, and then back home. So we'll have electricity flowing this way, magnetic field pointing up. We expect a force inward. And sure enough, we get an inward force.
很强吧?
Now, if I reverse the direction of the current, we expect an outward force. Get this guy out of the way. And there you see it, floating there. because now that I've reversed the direction of the current, current is flowing this way. Magnetic field is pointing up. We expect an outward force. And that's what you say. Right-hand rule, simplified.
Okay. So he also demonstrated how you apply your right hand to determine all the directions. And now I just repeat it again to make it a little bit more clearer. In this setup, the magnetic field is pointing from here to here, from the bottom to the top. And when there is no current, we just set our wire just there at the center of the magnetic field. And when the current is applied, now the current is going this way, from the back to somewhere in front of you. So this is going from this way to this way. And we just define a vector for it. So this is the vector for the direction, and this is the amount of your current. And if your magnetic field is going this way, and this is how the current flows, then you have the force going this way. Okay. Is it all right? Wait a second. Why do I feel like it's a little bit strange? Oh, yeah, it's okay. Yeah. We apply, we put our four fingers on the direction of the current. So this way. And, wow, this is hard. This way. And the magnetic field is going upwards, so it's going this way, and your force is pointing this way. Yeah, this is right. So the four fingers is on the white arrow direction, and then you turn your fingers upwards to the pink arrow. Then your thumb is going to the red arrow. So the four fingers, this is current. And your current is rotating into the direction of your magnetic field. And then your thumb is the direction of the force. 哇，对啊，我自己常讲到这边的时候，我都有点混乱。所以呢，你要先把你的4根手指头先放在电流的方向，然后把你的4根手指头转到磁场的方向，再来你的大拇指指的方向就是力的方向。我们通常都是会很直觉性的从磁场转到电流，所以你就会觉得，为什么我的指向跟实际相反？对，通常我们很快的就直觉性的就乱比，所以呢，我每次都要先想一下，电流是4根手指头，电流转到磁场，或者是我都要先看书先确认啊。对，我好像从来没有真的记得过。好，然后这是另外一个方向哦。So this is another case, but we are still applying the right hand rule. But this is now easier to look. So we have the 4 fingers going this direction, and we turn the fingers upward to the magnetic field, and then it's pointing. Yeah, now the direction is right to the direction of the force. 好。Okay, and here's the derivation. How do we get to the current from the equation of a charge? This is the equation for the charge. This is the Lorentz force, and this is the definition of the current. Okay, and here's a little bit complicated. So the current is from N. N is the density of the electric charge. So in such a volume, how many charges is in that kind of volume? So this is the density of the charge. And E, this is the unit charge in coulomb for 1 electron. 这个是一个电子上面所带的电量。And this is the drift velocity of your electrons. And A is the cross-section of the wire. Okay, so this is the Lorentz force and this is the current, and how do we link them together? So if we take just a little piece of current, so let's just set the length of your current is dl, so this is a small piece of your current, and the total number of charges inside that little piece is the number, the area, and the length. So this is the total number of the charges here. And this is the, and E is just the charge of an electron. So this one, this bunch of things is related to the Q. Okay. And then this is just the Lorentz force law, and now the velocity is the drift velocity, and then the magnetic field, the external magnetic field. Then the N and A and E and drift velocity is just equal to the current. And if we do an integration along the entire wire, you have the L, the length of your wire. And finally, this is the magnitude for and direction for your magnetic field. So this is how we get the Lorentz force law for the current on wire. 所以你经过这样子的推导，所以我们得到一个比较简单的形式。就假设说你不是一颗 charge， 你是一串电流的话，那么呢，你就是这样子，你就可以把导线上面的力，磁场是怎么样对你的导线施力的，你就可以用这条公式去做计算。Okay, then here is the versatile form. So if it's not a straight line, if your wire is not straight, and if your wire is curved, and if you just simply place it inside a magnetic field, then you can just calculate everything by integration. Yeah. So we just usually the current is constant. It's no reason that you have variable current. This is strange, and this you can take it as a constant, and you can do the integration from A to B, just integrate everything along the wire, then you can get the total force. Then magnetic force on a current loop. 哦，来了，出现了。好，在场的同学都已经拿到考卷。对，现在就请你麻烦你等一下。等一下可能会有些同学会陆陆续续会进来。And I am considering if I should go on or not. There are so many texts, there are so many exam sheets right there. Okay, let's go on. And then we are getting into the interesting thing. Electric motor. 那我们现在开始做很有趣的东西哦，很有趣但是很难，就是电动马达。So now we are looking at I find it really interesting and fun, but the physics inside is kind of difficult or complicated, but we just take a look at it. How you can create an electric motor. So this is the simplest and the mini motor. Somehow get a little curious. That's all.
Grammarly does more than catch errors. With Grammarly, you can find really good.
我突然有点好奇，下一个影片在干嘛？我们瞄一下。为什么会这样转？Why is it spinning this way? Somehow this is a very difficult question for me. This is difficult, right? I don't know how it works that way. Lens law is a little bit too. It's for the next lecture, but we can take a look at it now. Very slow, very slow. Ah, yeah, it's a little bit different. 大家观察一下那个中间那个心掉下去的速度，它突然有一种好像黏住的。你说呢？
我不知道为什么广告会变成这样，但我们就先在这里停住吧。好，这个影片不错，储存起来，稍后观看。好，让我储存一下。有趣。好，来临考卷的同学出现了嘛？那我们今天上课先上到这边。我们下次来解释为什么线圈会那样子转。So now it's time for you to pick your exam sheets up, and we just have the lecture up to here today. Next time we are going to explain why the coil is spinning in that direction. Hey, 什么？